Example number 6. So this is 0 to infinity of x squared e to the minus x cubed dx. Alright, so we're going to have to do a u sub on this, but first let's deal with the limit part, because that's actually relatively quick. So we have limit as b goes to infinity, and we're using b because it's the upper value, of 0 x squared e to the minus x cubed dx, and its upper limit is b. Now there is a definite integral in here, and so we just have to worry about that and then evaluate it and do the use, and then evaluate the limit. In order to evaluate this, though, we have to do a u sub. So our u is going to be minus x cubed, and then you take the derivative of that, you get minus 3x squared dx for your du. And so we have most of the du components, but we're missing the minus 3, so we need to put that in there. And of course we have our u here. So I'll write it in another step. Okay, so still have this limit. That's going to be hanging around for a bit. 0 x squared e to the minus x cubed dx. Okay, and what we need to make this u sub work is a minus 3 here, and we have to keep this balanced. So we're going to need a minus 1/3 outside. Now we have our du, and we have our u here. So we do the u sub. Just let's see if that works. So that's e to the u du. Okay, that's good. Now, because this is a definite integral, remember that the bounds have changed. So you could evaluate them, but in this context, as you have a limit, it's better to just plug it in and then to find the antiderivative, plug it in, and then go back to x to evaluate the limit. 0 and b there, remember. So they change. We have this minus 1/3 to keep it all balanced, and we still have this limit hanging around. So that's going to be there for a while. Okay, the u sub was successful. So the antiderivative of e to the u is e to the u. That's good. We have to change back. Remember that, which we'll do shortly. And we still have this limit here. Okay, so subbing back, this becomes e to the minus x cubed. We're evaluating from 0 to b, and we still have this limit as b goes to infinity. Okay, plug into the antiderivative, so e to the minus b cubed minus e. Wait a minute. Minus 0 cubed. Okay, so there needs to be a minus 1/3 there, minus 1/3 here, minus 1/3 there. Okay, still have the limit. B goes to infinity. So this is e to the 0. We have a minus 1/3 in front. So e to the 0 is 1. So this is minus 1/3 minus. So that cancels to become a plus. So, okay. So we have minus 1/3 e to the minus b cubed plus 1/3 limit as b goes to infinity. Now we're ready to evaluate the limit. So this is again b going to a huge number, and now we have, so we're going to have a huge number here, but we have this minus sign. So this is going to be e For the negative huge, you have a constant in front of it plus a third. So because it's negative, this term is going to be 0. So we have 0 plus 1/3, and so the overall result is 1/3.